Bismillah ar-Rahman ar-Rahim. This is a very short lecture which will follow the discussion of an thesis made by Dr. Rana Sobhi. We will discuss it next Saturday, tomorrow, inshallah. The title of the thesis is Wound Infiltration Using Bupivacaine versus Bupivacaine with dexmedetomidine or ketamine for postoperative analgesia in Caesarian section. So this is a small talk which will follow, inshallah, the discussion. This first slide shows, first of all, how to estimate the sampling size whenever you want to make a thesis. You can see the abbreviation, the Z value, which is well known in statistics whenever you're using more than 20 or 30 individuals. This is a simple figure showing how to estimate. The advantage, of course, of addition and some points with the thesis that we have a method of continuous, of course, injection of the local anesthetics through a special designed casters where they can be trimmed, or they have a special length of orifices where we can continue inject local anesthetics. And these casters are made mainly of silver coated, so to protect against infection. And we use always gauge 20 in such circumstances. And these are the three systems used for continuous injection. Of course, we know the elastometric method used for PCA. And this is the method how to inject local subcutaneous. You must pinch the skin, then inject, and then leave the pinch, you see, so that you will not go to the other side. And this is the special syringe used for local anesthetic to better control the injection. You see, you catch with your fingers and the thumb. This second slide, first of all, shows the field block. What the advantage of the field block? Whenever you have a skin incision, suppose this site of incision, you inject around it, sparing the area of the incision, where, of course, we can use less solution, and we will not induce an anatomic distortion. Healing is not going to be affected. And surgical side may be trouble some or harmful, as avoid the rupture of a cyst or spreading a malignant cell. These are the advantages of using what we call a field block. This is the figure we'll mention later on, which denotes the continuous subcutaneous injection device. And this is the areas where we inject. We have the epidermis and the dermis and the hypodermis and fascia and the muscular layer, where we are capable of course, inducing the toxic local anesthesia when we reach this area. Subcutaneous injection doesn't have much blood vessels or nerves, so you don't have to aspire while you are injecting. You ought to go if you are doing intradermal injection with the needle in a perpendicular way, and it ought to be short. And if you are going to go deeper structure, use an angle of 90 degree. This slide of course, somatic pain, mainly it's initiated from the deep structures as the periton and the muscle. So you ought to inject deeply enough to block all such areas and to reach the block of the somatic and the visceral pain. The preparation of the lysosomal bupivacaine is special preparation. Where we can have the bupivacaine enclosed in a bilipid area, which gives a slow release, and it can give a duration of action of 96 hours. Or we can incorporate it in a microcapsule or microsphere, which will last for, I'm sorry, this will last for 96 hours. And then we can also induce a permanently charged quaternary ammonium. You know that the local anesthetics must be present in the two forms. First of all, the basic lipophilic form, where it can penetrate the tissue. And after penetrating the tissue, it becomes ionized, you see, so that it can affect the sodium channels. But here we are inducing a permanent quaternary charged quaternary ammonium, inducing what we call ionic trapping. So the drug is entered and is kept inside the sodium channel for a longer time, so it can give me give us analgesia for around from 12 to 16 hours. The advantage of local anesthesia injection, it affects the inflammatory response, which normally sensitize the nociceptive receptors and contribute to pain and hyperalgesia. A local anesthetic inflammation reduces the release of inflammatory mediators from neutrophils, reducing neutrophils adhesion to the endothelium, reducing the formation of oxygen radicals, and decrease edema formation. All these are the advantages of giving local anesthetic subcutaneously. Of course, whenever I use subcutaneous injection, we have to have special characters. Of course, we ought to minimize the injection speed, and we ought to minimize the volume, and we must limit the osmolarity of the fluid to 300 millimole per kilogram, not increasing more than 600, so to decrease the incidence of pain. This setting shows what we call the siliconized barrel. This makes it easy to move and easy to be injected. Of course, there are preservatives in the local anesthetics, which increase the pain. We have the encresol, more painful than benzyl alcohol or phenol. And if we buffer the local anesthetics, of course, the sodium bicarb, and we can have phosphate or citrate buffers to minimize the pain during injection. The silicone needle, coated needle, of course, it minimizes the pain. It makes the introduction easier, and it prevents sticking to the skin, you see. So these are the advantages of silicone coated needle. And as we said before, whenever I inject, I ought to use an angle of 45 or 90 degree. And these are the different size of needles used, from 25 gauge to 30 gauge, and this is the diameters of it. And this is the length of the needle. And as we said before, we ought to use what we call the pinch type during injection. Tumescent analgesia, it's used by the plastic surgeon, where they use too much local anesthetic on the expense of the concentration, minimize the concentration. This is what we call the tumescent analgesia, and this is the device for continuous injection. This last slide will show the liposomal bupivacaine, which has been approved by the U.S. Food and Drug Administration, infiltration for pain, for prolonged pain relief. And then we will discuss some points regarding statistics. First of all, the p-test statistic, which was invented by Joseph. William Joseph, where he was asked to compare two fields of barley. So he had to take samples from each field, and he wanted to share this results with his fellow statisticians, but the company, Burley company, Guinness, refused to do so. So they had to call the test student test instead of Joseph test. So he takes samples from this two fields and compare the two samples. So he performed what we call two histograms. As you can see, we have a mean and we have a variability of this spreading of this bell shaped, and we compare both of them, comparing their mean. Of course, the mean is not all the story, but the variability of the results on both sides are important in comparing both of them. Of course, first of all we get what we call the t-value, and then we go to a special tables. These tables can from the degree of freedom can estimate from the magic 5% the hypothesis, whether it is a null hypothesis or it is null hypothesis, to say whether these results are statistics or non-statistics. So this is the bell shaped, and this is the mean of the figure. Suppose this is the amount average of hemoglobin among men. The mean is 160 gram per liter, and then we spread on both sides. The spreading is called sigma, which is the standard deviation, and then we have around 3 standard deviations. The area most probably comprising the most of the patient is around 95%. This is why you call 95 confidence. And then the tails are around 5%. So when the results are less than the 0.05%, we call it that it is significant. If it's small, it is not significant. So this is the Gayson shape bell of the normal distribution. You have to have a normal distribution so that you can use the t-test. Another tests are being used in case we cannot gain this normal distribution. So comparing suppose two normal distribution of two, as we said before, two fields can make us know whether the results are statistically significant or not significant. This is called unpaired. Unpaired, that we are comparing only the two fields, the two samples of the fields, and we are not in. If we say paired, each I can add an additional statistic to one of them. Suppose I want to add a fertilizing material to this field during comparing both fields. You see, so this is what we call a paired. But this as we said before, is unpaired. You see, you are comparing only the both fields regarding the amount yield of the barley field. The second test, which will be incorporated in this thesis, is chi-square test. Chi is the 22th letter of the Greek alphabet. As you can see, it is written as if it is X, and it is squared, and then this is the sum. It is a comparison between the observed, this is observed, and expected over the expected. What's the meaning of that? Suppose I have 100 of coins, and then I began to throw this 100 coin. I flip these coins. You see, so I'll suppose I get whatever 73 head, and the rest of them tails. Is this significant? Is this significant, or it is based on the shape of the coin, or I'm doing something wrong? You see, so this is the whenever I apply expected. Of course, I expect that 50-50 will be the end result, but it's not really. You see, so I'm comparing what I had observed to what I am supposed to expect. You see, and then this will go to a special tables, as we know that knowing the degree of freedom reaching to the null hypothesis. You see, or it is null hypothesis. It is really significant. From this tables, I can know from the magic critical value, which is 0.05%, whether this results are by chance, or actually there is something wrong in the coin. Suppose I made a coin with a special form so that it can yield head more than tails. You see, so this is the idea of the chi-squared test. The third test is the ANOVA test. As you can see, the ANOVA test is the test where I compare more than two groups. As you can see, there are three groups with three figures. From these three figures, I can estimate the mean, which is the X bar, or we have a grand mean, which is the mean of all of them. We call it grand mean. It is 2 dashes over X, and we go through 5 steps there. We reach the end result of the hypothesis, whether it is significant or non-significant from the magic table, which is 0.05. This, whether it is less, it will be significant; more, it will be non-significant. The last point is to show one of the instruments that are used for continuous subcutaneous injection. So this is
injection technology improves the dispersion of medication throughout the tissue as compared to a needle-based injection. To really understand how needle-free injections work,
follow
below the surface of the skin.
See how does it inject?
As the plunger on a traditional needle
the traditional.
A spherical pool of medication called the bolus forms at the tip.
See the bolus?
With needle-free injection,
free, no injection.
Itself penetrates the skin. As it
spreads
the tissue, it follows the path of least resistance, resulting in a widely dispersed spiderweb-like distribution of medication. The bioinjector is powered by compressed CO2 gas.
CO2 cartridge.
The actuator is pressed, the CO2 is released, and the medication is forced through a tiny orifice at the end of the syringe. The gas exits from vents at the rear of the device and does not come in contact with the medication. The reservoir is automatically filled, ready for the next injection. When used properly, each new CO2 cartridge is designed to deliver 8 injections within a 24-hour period. There are 4 main steps in using the Bioinjector 2000 needle-free injection system. First, insert the CO2 cartridge. Next, fill the syringe. The bioinjector syringe can deliver doses from 1/10 of a cc to 1 cc. Insert the filled syringe into the bioinjector and give it a quarter turn to lock it into place. Then, after preparing the site, position the device and administer the injection. Discard the used syringe, and you're ready to get the next injection. The Bioinjector 2000 has set a standard for comfort, safety, and convenience in needle-free delivery of intramuscular and subcutaneous.
My colleague, after making this thesis, concluded that using Catalar with bupivacaine as a subcutaneous injection for Caesarian section definitely increases the pattern of analgesia and decreases the time for the first rescue analgesia. On the other hand, the dexmedetomidine has induced some sort of bradycardia. As we know, it is a drug which can induce bradycardia and hypotension and so forth. So this were the results that she achieved from this result, which we will discuss on Saturday. Thank you very much. Wassalamu alaikum wa rahmatullahi wa barakatuh.